Okay, so you say 9 and 10 out of 2, 3.
And then, yeah, and whatever else you
Okay.
think might be helpful.
I might look at a few of those. Anything out of 2, 4? Have you looked at any of those yet?
Maybe like number 2, 5,
Okay.
6, and whatever else you recommend.
Okay. Yep, I can see if I can't find a couple more out of those. Did you look at any of the ones out of 2, 5 at all? We only did 1, 2, 4, 5, and 6. Those are what we did last time. I do which one?
Oh, you did those things?
Yeah, on the homework, remember, out of 2, 5, we assigned 1, 2, 4, 5, and 6 is what we assigned. Would you like me to look at one of those then? 2 of those? Sure. Okay. Yep. It's an application. Sure. Yep. We can look at those, and we'll go through these, and then we'll see if we need to add some more. So we'll start with these. So we'll look at 2, 3. We'll look at question number 9. 2, 3, I believe, is an easier section, if I remember right. I think it's.
2.1. I actually really enjoyed that chapter.
Do what now?
2.1, I really enjoyed that one.
Yeah, that was not too bad. 2, 2 is not bad as long as you remember how to work with the circles.
Yeah.
Okay, so we're going to now look at 2, 3. Question number 9. And this is just looking at a graph here. And they just want you to find, or not, just find out if it's a function or not. So we don't have to find the domain, range, none of that. So our picture looks like this. And how do we tell if it's a function or not? Remember? Well, we have what's called the vertical line test. And so how does the vertical line test work? Well, the vertical line test says if we draw a vertical line, and that vertical line touches the graph at more than one place, like this one does, then it's not a function. So see how it overlaps itself here vertically? That means it's not a function. And most things are functions. It's just that one overlaps itself. And so that would make it not a function. And question 10, this is also not a function. We need to find our domain and our range. And when we look at this graph, we know it's not a function again because of the overlap part here, right? The domain is the values of x. And what we look at is we see if we can go to the left and we can go to the right. Well, this has arrows here. So if I follow this graph, it's going to go all the way back to the left, isn't it? Right? Down and to the left. And if it goes up this way, what does it do? It goes up and to the right. So it goes to the left and it goes to the right. So my domain would be negative to positive infinity because it goes left and right. Now, what about the range? Well, the range is the up and down part. And what about this? Well, this arrow means it goes on forever. So if I kind of follow it here, as it goes to the left, what else is it doing? It's also going down, isn't it? So it goes down to negative infinity because it would keep going down further down. What about the other way? If we go to the right, what does it do? It's going up. So it goes all the way up and all the way down. So my range, which is the y component, would also be negative to positive infinity. Does that make sense on that? But like this one would not be the same domain. The range would be the same because it would go up and it would go down. So the range would be the same, but the domain would be wherever it starts at. And so it'd be like at -5 for the domain to positive infinity, because it can't go past that -5. Does that make sense now? Okay. So that takes care of those two. And now we'll look at 2.4, which is slopes. So 2.4, we'll look at questions 2, 5, and 6. So we want to graph this function and also find the domain and the range. So this is 2.4. We're going to look at question 2. And our function is f of x equals 1/4 x. And that f of x, well, that's the same as y. So we could actually rewrite this as y equals 1/4 x. Okay? Now, if I want to graph this line, it's been solved for y. We need a slope, and we also need a point. So my slope would be here, and my slope would be 1/4. Now, what about the y-intercept? Well, is there a number on the end here? Is there a number added on the end? No, right? So that would make it then 0, 0. Because that's like having a plus 0. So we're going to start at 0, 0. And then my slope is 1/4. So that means we go up 1 and we go over 4. So we start at 0, 0, and we go up 1, and then we go over 1, 2, 3, 4. Up 1, over 4. We make our second dot, and then we can simply connect them together. And there is your line. Does that make sense so far? Now we also need to get our domain and range. And our domain is the values of x. So just like we did before, this one goes out to the left, up to the right. So my domain would be negative to positive infinity. Same thing for the range. It goes up to positive infinity, down to negative infinity. So my range would also be negative to positive infinity. So that one was just graphing it and also finding the domain and the range. Question 5, we want to find the average rate of change. Well, the average rate of change is just another word for the slope. So the average rate of change is another word for the slope. So let's look at our graph. And what we're looking at is we're looking at the value of a car. Let me brighten this up a bit too. There. That makes it too much. So we're looking at the value of a car. And what do we know about the value of a car? Well, the value of a car is always going to go down, right? You put miles on it, it gets older. Unless it's a rare antique car, value is going to go down. We are looking for the average rate of change. And we're going to do this with ordered pairs. Our average rate of change should be negative because this car is going to lose money. And we'll just find our ordered pairs here. So this ordered pair, there is 0. This ordered pair is at 0, comma, 20. So we bought the car brand new and it cost us $20,000. Then 5 years later, the value of the car is only what? Is only $15,000. So there's our two ordered pairs. You see how I got those in the picture? Okay, and we know our value should be, average rate of change should be negative because these values are decreasing. The car is always losing money. And so we've got our ordered pairs. We've got 0, 20, and we've got 5, 15. We're going to use our slope formula, which is m equals y1 minus y2 over x1 minus x2. And we'll go ahead now and plug our values in. Label your ordered pairs x1, y1, x2, y2. So plugging them in, we get 20 minus 15 over 0 minus 5. And 20 minus 15 is a 5. 0 minus 5 is a minus 5. So that means we have a negative 1. When we look at our picture here, this is the value of the car in thousands of dollars. So we didn't lose 1, we lost $1,000 per year. So every year, that car is losing $1,000. So do you see how I did that? Got your two ordered pairs and then use your slope formula. A lot of these are just trying to figure out what to do, what numbers I plug in, and how to use the formulas. And question 6 is the same as well. So question 6, we've got a table of the values of the stock. And April is 1. So April is x equals 1. So May would be 2. June would be 3. 4, 5, 6, 7, 8, and 9. Okay, so that's how they labeled them, because April was 1. And it increases one number each time. Now we want to find the average rate of change. Again, so that's your slope. And this is your x value, and this is your y value. And we want to look at the average rate of change between June and September. So we need to find our values. We want June and we want September. So let's make our ordered pairs and apply our formula. So we want June, and June as an ordered pair would be the third month that we've had the stock, and that stock was worth $89. Then we look at September, and in September, that's the 6th month that we've had the stock, and that stock is worth $111. And so what's happening to the value of that stock? Well, over time, that stock is increasing in value, right? If I look at 89 to 111, that's going up. So our average rate of change, or our slope, is going to go up because this stock is making money. So now we apply our slope formula. M equals y1 minus y2 over x1 minus x2. But do you see where I got the ordered pairs from, Megan? Does it make sense? Okay. And you just have to label them because it says your month. You start off with April. And it has that 1 there. So 2, 3, 4, 5, 6, 7, and so on. Okay, so let's go ahead and work this out. And so we've got 89 minus 111 over 3 minus 6. 89 minus 111. That's a difference of a minus 22. And 3 minus 6, that's a difference of a minus 3. Negative over negative makes that a positive value. And so that's going to come out to be about $7.33. And that is how much we make per month. So on average, between June and September, that stock made us $7.33 every month. So slopes are average rates of change. Now, if we would have extended that out to December, then we would look at losing money. Because in December, it's only $65. So then it would have been a negative value. But this one, between those 3 months, was a positive value. Now we'll look at a couple more questions out of 2.5, and then we'll finish up 2.5. Okay, 2.5, we're going to look at question 1. Okay, so for this question, we're trying to find the equation. And we want to find the equation given these conditions. And we're looking at finding the equation when you're given a point and a slope. So both of those are provided here. So we want to find our equation, and we want our equation written in slope-intercept form. So that's what we're wanting here. Okay, let's see, I've got that page around. Well, last week I gave you that handout. Do you remember that handout? So what do we have now? And if you've got it, you can look at it. We're on that first page. We have a point and we have a slope. So we're going to use the point slope formula. So we have a slope of -9, and we have that point -9, 2. So we already have a point and a slope, so we use point slope. And point slope is y minus y1 equals m times x minus x1. So x minus x1. And this is your x1. This is your y1. Plugging our values in, we get y minus 2 equals a -9 times x minus a -9. Where you want to be really careful at is the negatives, the signs. So we have some double negatives here. And this double negative here is going to make that positive, and we still have to distribute that -9 through. We want it in slope-intercept form, so all we'll have to do is solve it for y. So that leaves me then with y minus 2 equals minus 9x, distributing through a minus 81. We can go ahead and solve this out by simply adding that 2 over. And now we've got it, because now we've got our answer in slope-intercept form, which is y equals a minus 9x minus 79. And that is your answer in slope-intercept form. We're going to look at one more of these, which is question number 6. Question number 6, we're going to have to come up with our formula. And question number 6 is an application. And we need to come up with our two ordered pairs. So we can use those two ordered pairs to find the slope. So the amount of time t it takes for a flame to go out of a closed container is a linear function of the volume of the container, x. So x is going to be the volume. A flame in a container that has 740 milliliters takes 14 seconds to go out, and a container that has 1,100 milliliters of air takes 22 seconds to go out. So of course we know the larger the container, the more oxygen's in there, so the longer it's going to take for it to go out, right? So our slope, our average rate of change, should be a positive value. Increase the size of the container, increase how long it takes for the flame to go out. So we're going to come up with our equation, and we're going to have x be the volume. And y is going to be the time, because it says x is the volume. So we'll let y then be the time. You can use a t, but we're used to using the y, so we're just going to use that y then. So y is going to be our time. And we need to come up with our ordered pairs. So what do we know? Well, the first container is 748 milliliters. And it takes 14 seconds to go out. So there's our first ordered pair. Our second ordered pair is 1,100 milliliters, and it takes 22 seconds to go out. So do you see how I got my two ordered pairs there? So always look and see which one is the x, which one is the y. So they said x was the volume, so that means y is going to be the time. They use a t, but I think that's confusing because we're so used to using the y, just use a y. So y is the time, x is the volume. Make your ordered pairs, and now we're going to go ahead and find our slope because we've got two ordered pairs. And we always need to come up with a slope somehow. So two ordered pairs means we have to use our slope formula. So y1 minus y2 over x1 minus x2. And we simply plug our values in. So that's 14 minus 22 over 748 minus 1,100. And let's see what that gives us. Should be a positive value because the larger the container is, the more time it's going to take for that flame to go out. So the numerator is a minus 8. Denominator is a minus 352. And I think that 352, I think it's divisible by 8. And it is. Negative and negative makes it a positive 1 over 44. So we just reduced it down to a positive 1 over 44. Now, once we have our slope, what's our next step? Just like we did before, once you have that slope, then you use that point slope formula. So that's our next step. So now we're going to use point slope. And we're going to use that point slope formula with an m of 1 over 44. And we'll use that ordered pair, 748, comma 14. Our formula is y minus y1 equals m times x minus x1 And now we just plug our values in. So that's y minus 14. That goes on the left. And that then equals 1 over 44 times x minus 748. Distribute that 1 over 44 through. And we're going to get rid of the fractions in a moment. So don't worry about that at all. They're going to go away shortly. And so that leaves you with 1 over 44x minus 748 over 44. And that equals then y minus 14. And we'll quickly get rid of the fractions by multiplying it by 44. So we'll use that 44 there. And when I distribute that 44 through, then I get 44y minus 616 equals, those cancel, x, those cancel, minus 748. We're solving it for y, so we'll add that 616 to each side, and we're almost finished here. So adding that 616 to that negative 748 gives you then a minus 132. And we'll divide by our 44. And we want to reduce this down as far as we can. So that gives us then y equals 1 over 44x minus 3. Because 132 divided by that 44 makes it a 3. So that is our equation in slope-intercept form. Does it make sense how we did that? So just clear out that 44, move things around. And you've probably seen this in previous courses. I know in previous courses we've done these very same problems. Okay, let's go ahead now and we'll look at some special cases quickly here. And then we'll come back after a short break and look at some of these where we talk about parallel and perpendicular lines. But right now we're just going to look at some special cases. Then we'll talk about parallel and perpendicular lines. So let's look at this one. Let's say you're given the point 4, negative 8, and you're given a slope of 0. When you have a 0 slope, is it a vertical line or is it a horizontal line? Do you remember? Yep, it's going to be a horizontal line, right? And so a horizontal line is like this. So a horizontal line, it crosses the y-axis. So your answer then, if you're given this point and a slope of 0, your answer then is going to be a y line. And what's the y component of your ordered pair? The y component of your ordered pair would simply be negative 8. So your answer, if your slope is 0, is a y line, and in this case it would be y equals a negative 8. And that's your answer. Now, what about an undefined slope? So a zero slope was a horizontal line. So an undefined slope would be the opposite. Let's say I give you 3, -2 for your ordered pair, and I give you a slope that is undefined. So if I give you an undefined slope, what does that mean? Well, that means it's a vertical line, and that's up and down, so that crosses the x-axis. And where does it cross the x-axis at? Well, we need the x component of your ordered pair. And so in this case, the x component of your ordered pair would be what? Would be simply 3. And so that's your answer for that, x equals 3. So what do we need to take away from that? If your slope is 0, what is it going to be? Horizontal line, which is y. If your slope is undefined, what is it then? Vertical line, and it's an x line. Now we're going to look at these when I give you a point and a line equation, and it's either going to be parallel or perpendicular. Now, parallel lines have the same slope, and perpendicular lines have the negative reciprocal slope. So we'll just do some of the special cases now, and then we'll do the ones with the algebra right after our break. So let's say you're given this ordered pair, -9, 10, and I want it to be parallel to the line x equals 15. There's no calculations involved in this. When we talk about parallel, what does that mean? Okay, parallel lines are in the same slope. So if they're like this, they're going to be both vertical or both horizontal. So x is parallel to the x. So we're looking at an x line. And so in our case, when we look at our ordered pair, what's the x component? -9. So what would be parallel to that line, x equals 15? That goes through 9, 10. Well, that's going to be an x line, and that's going to simply be x equals -9. So x is parallel to x. What about y? Well, y has to be parallel to y as well. So let's say you're given this point, 4, 2, and we want it to be parallel to y equals -9. Well, what do we know about parallel? Parallel, again, are the same. So they have the same slope. So that means that y is parallel to y, and so this one would simply be y equals 2. That's it. So we've got our ordered pair. We want it to be parallel to a y line. And what's parallel to a y line? Another y line. Let's look at one more, and then we'll take a short break, come back, and do all the ones that require algebra. So let's say you're given, again, another point. How about -4, 3? And in this case, we want to be perpendicular to y equals 7. This one's a little bit different. This one is perpendicular. Y is parallel to Y, X is parallel to X, and what about X and Y? Well, they look like this, so they're perpendicular to each other. So X and Y are perpendicular. So in this case, we've got Y equals 7. So it's a Y line. What's perpendicular to Y? X. And what's the X component of this ordered pair? Yep, -4. So what would your answer simply then be? Yep, X equals -4. We'll take a short break and we'll come back and we'll look at all the ones that require algebra.